All right, section 2 of chapter 3, we're going to take all of those definitions that we talked about in section 1, and we're going to add a little bit to those, look at what type of relationships are actually happening between the pairs of angles. And so in doing so, we'll start using those same terms. Friendly little reminder that I do have some video notes if you want to print those out before watching this video so that you can follow along and fill that in as you go. So here we go. Just a reminder, parallel lines are when two lines are coplanar and they do not intersect. So you have two lines that are never going to cross. So we talked about here how line M and Q are parallel to each other. There's our notation. And a lot of times you'll just see some arrows noting that these two are parallel to each other. Parallel lines is something that you cannot assume. It has to be given to you. And so now if you look at what's going on here with some angles, I have two sets of parallel lines with a transversal going through with some angles going on. So you'll notice that I have 4 angles here, and here's another 4 angles that are created with these 3 lines. And try and see if you can figure out what's happening with all of these. We should be able to see vertical angles, and the fact that vertical angles are always going to be congruent to each other. So we've got all of those as we go around this entire diagram. We also have angles that are supplementary to each other, so they have to add up to 180 degrees and so on. But then start to look at, well, what else is going on? And hopefully you're starting to see that those angles that are created up above here are the exact same angles that are created down below. You have the exact same angles. Same thing over here. We've got 30, 50, or 130, 50, 130, and 50. We have those same 4 angles down below. And this all comes with some theorems and some postulates that are used to show the different angle relationships that there are. So I'm going to start out by looking at what's called the corresponding angle postulate. So you should see a word that looks familiar here from yesterday, and that's the corresponding angles. Remember, corresponding angles are the angles that are in the, as I like to say, the same corners. So angles 4 and 8, 1 and 5, 2 and 6, and 3 and 7. Those are our corresponding angles. Well, what happens here is if two lines are parallel and they're cut by a transversal, which I have T, then each pair of corresponding angles are going to be congruent to each other. So I have M and N being parallel to each other, and then T is the transversal line. And so what's happening here is now we end up with congruent angles. 1 and 5 are congruent, 2 and 6, 4 and 8, 3 and 7. The corresponding angle postulate. So corresponding angles are congruent, and so this means that angle 1 is congruent to angle 5, angle 4 is congruent to angle 8, angle 3 is congruent to angle 7, and angle 2 is congruent to angle 6. Next, we're going to bring back the alternate interior angle theorem. So alternate interior angles, first of all, interior angle being the angle that's inside the 2 lines that are cut by the transversal. So we're talking about angles, you know, our interior angles here are 3, 2, 8, and 5. And with those, we have alternate interior angles, which are opposite sides of the transversal. So 3 and 5. And 2 and 8. And what the alternate interior angle theorem says is that if 2 parallel lines are cut by a transversal, then each pair of alternate interior angles are congruent. So not only are corresponding angles congruent, but alternate interior angles are also congruent to each other. So this means that angle 3 is congruent to angle 5, and angle 2 is congruent to angle 8. Now, alternate interior, now we're going to transfer over to alternate exterior angles, and you might be able to kind of figure out what's happening here. Now, Alternate interior angles, they are vertical angles to our alternate exterior angles. If I think about here, 2 and 4 are vertical angles, and so are 8 and 6. Well, then you end up with angle 4 and angle 6. Those are alternate exterior angles. And so we end up with, if the alternate exterior angle theorem, which says that if two parallel lines are cut by a transversal, then each pair of alternate exterior angles are congruent. So 4 and 6 have to be congruent, and 1 and 7 have to be congruent as well. Alternate exterior angles are congruent to each other. Angle 1 is congruent to angle 7, and angle 4 is congruent to angle 6. So you have corresponding angles which are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. So we've gone through almost all of them, except we're missing 2 more. And I'm going to go back to this original drawing that I have. And the one that we have not talked about yet is consecutive interior and consecutive exterior angles. So if I look at consecutive interior, we're talking about these 2 angles that I highlighted in yellow, these angles right here. These are all consecutive interior angles. And if you look at those, you'll see that they're not the same measure, but hopefully you're seeing that they are adding up to 180 degrees, meaning that they have to be supplementary to each other. If we then look at consecutive exterior angles, so if I look at the purple there, if I look at the 2 green ones here, and I look at the yellows, and I'm missing the blues, notice that the consecutive exterior angles are also adding up to 180. So here we're adding up to 180. These 2 angles added together are giving us 180. So we have all of that going on. So going on to consecutive interior angle theorem. If 2 parallel lines are cut by a transversal, then each pair of consecutive interior angles, here we just need to be careful that we're not saying that they are congruent, but that they are supplementary. So that they are So if they're supplementary to each other, that means that it's going to add up to 180 degrees. Interior angles, I'm talking about 3 and 8 and 2 and 5. So we can go ahead and say that the measure of angle 3 plus the measure of angle 8 has to equal 180. And we can say that the measure of angle 2 plus the measure of angle 5 equals 180. Consecutive interior angle theorem is going to be the same as the consecutive exterior angle theorem. We're just talking about different angles. So this theorem says if 2 parallel lines are cut by a transversal, then each pair of consecutive exterior angles are also going to be supplementary. So angle 1 and angle 6 are consecutive exterior angles, and angle 4 and angle 7 are. So consecutive exterior angles are supplementary. And that means that the measure of angle 1 plus the measure of angle 6 equals 180. The measure of angle 4 plus the measure of angle 7 is also equal to 180 degrees. So we've gone through pretty much our do their corresponding. We did our alternate interior, alternate exterior. The only one here that I'm going to add on is remembering our vertical angle theorem, which says that if you have vertical angles, that they are going to be congruent to each other. So vertical angles, we're talking about angles 4 and 2, 3 and 1, 8 and 6, and 5 and 7. So those are all vertical angles. So angle 4 is congruent to angle 2. Angle 1 is congruent to angle 3. Angle 5 is congruent to angle 7. and angle 8 is congruent to angle 6, and that's our vertical angle theorem. Linear pair, a reminder about that. A linear pair is when you have two, we won't use this one a lot, but just it's a friendly reminder here. Linear pair is when you have two angles that are adjacent and they are supplementary to each other. So we're talking about 4 and 1, 1 and 2, 3 and 2, and then also 4 and 3. Those are our linear pairs. And linear pairs of angles are supplementary. I'm not going to list all of them here, but the measure of angle 4 plus the measure of angle 1 equals 180. The measure of angle 5 plus the measure of angle 6 equals 180. And there's a lot of different pairs that can be written out here, 8 of them to be exact. So what we're going to be doing in class then tomorrow is we're going to be looking at, how do you take a problem here where I have two lines that are parallel, and if you're only given one angle, how do you find all of them? So if I'm just given this 143 degrees here, how do I find the remaining angles? What I'd like you to do is to come to class with this example figured out. I am telling you here that these two lines are parallel to each other, and I would like you to find the remaining angles if I give you this angle here is 143 degrees. So please bring that with you to class tomorrow. If you have any questions, make sure you write them down. Otherwise, we'll see you in class.